Okay, one more question about this integral that we're looking at. Is the value of g of 0, they say, a positive or a negative result? Verify your answer. So, to remind you, our function here is 4 minus x squared, and g of x is the integral of that function, 4 minus whatever variable, going from 1 up to x. Only in this case, they've told us this is going to be 0. So there's not really any need to leave it as a variable anymore. We can just say the integral from 1 back to 0. And they ask, will that come out positive or negative? Now, take a minute to think about that. There are two factors you have to consider here. One has to do with height, and the other one has to do with direction, if that tells you anything. Pause this if you want to think for a bit. Cast your vote, and then we'll run this off and see what actually happens. When we do this integral, we have to do an antiderivative, which is easy enough. We get 4t for the first term, minus, and then the power of t goes up to 3, and then we divide by 3. So that's our antiderivative, and we're evaluating that from an upper bound of 0 and a lower bound of 1, which means first I take this antiderivative and plug 0 into it, which means 4 times 0 minus a third of 0 is 0, minus, and now I do the same thing with 1, where I get 4 times 1 minus 1/3 of 1. So we get 0 minus 4 minus 1/3 is 11/3. Comes out to negative 11/3. Did you see that coming? If you didn't think about it quite enough, you looked at this and said, well, all of that is above the x-axis, therefore it's positive area, therefore the answer should come out positive. And if you thought that, then everything you thought there was correct. But there's one more factor that comes into it, and that is the direction of integration. This is supposed to be your lower limit, and this is supposed to be your upper limit. And so when you go this way, the integral expects, so to speak, that your x's are going to be increasing, that they will start at 0 and go up to 1. And when that happens, then these rectangles have positive width. But that's not what happened here. We integrated from 1 down to 0. We were going from right to left. If you integrate from right to left, which we normally avoid doing, then the integral thinks x's are going down, therefore their widths are negative. And so when it finds the areas of these rectangles, it says, okay, they have positive heights, they have negative widths, these areas are coming out negative. That's what happened down here. So we won't normally do this, set these up on purpose. We will normally go from left to right and try to have positive heights where we can manage it and have nice positive areas, because we're sane people and we don't want things to be messier than they have to. But be aware, negative heights can make an area come out negative, and going in the wrong direction, right to left, can also make areas come out negative. So the answer to this is you get a negative result, and we can see it coming because our direction of integration is out of whack. We went from a higher number towards a lower number, and that's not how it's supposed to be. This is supposed to be your lower bound. This is supposed to be your upper bound. So if you were setting up this integral, this isn't part of the question anymore, but just so you know how this works. If you wrote this integral, you might look at this and say, wait, that's going to give a weird result. And you could just switch this to integral 0 to 1, 4 minus t squared dt. And that adjustment alone would cause this integral to come out positive now. If you didn't want a negative answer for whatever reason, you could make this little tweak and get a positive result. As long as you know that it's safe to ignore the negative sign this is trying to give you. If you know that negative isn't meaningful, this is the quickest way to get rid of it. Just switch your limits of integration so they go from low to high.